So here we have the same result that's in the thumbnail, and this is the result we're trying to prove. Again, we're going to prove it in the 2x2 case. So we're trying to prove that matrix A and B, if we multiply them together and then take the transpose, this is equal to the transposes multiplied together, but we have to swap the order. So B transpose multiplied by A transpose. I'm going to start with the right hand side here, and note that we're going to begin with A is just equal to A11, A12, A21, A22, and similarly B is equal to B11, B12, B21, and B22. Okay, so what we're going to do now is take B transpose. So to take the transpose of a matrix, basically swap the, not basically, we actually swap the rows and the columns over. So we get B11, B12, B21, B22. Notice the diagonal elements stay in place. And then A transpose is equal to A11, A21, A12, A22. Okay, so now we're going to take the product of these, so B transpose, A transpose is equal to, and we'll just write these out quickly, B12, B22 multiplied by A11, A21, A12, A22, and then we just multiply matrices in the normal way. So we go across the rows here and down the column. So in this one we get B11, A11 plus B21, A12. For the next component, we're on the first row, so we go across the first row here and then put the second column. So we get B11, A21 plus B21, A22, and that should give us enough room now. This one on the second row, first column of our new matrix, so we go down across the second row down the first column. So we get B12, A11 plus B22, A12, and then we for the last one here in the second row, second column, we go across the second row down the second column, so we get B12, A21 plus B22, A22. Right, now I'm going to stop here with the right hand side, and I'm going to go from the left hand side, and I'm going to consider first A times B. So this is A11, A12, A21, A22 multiplied by B11, B12, B21, B22. Okay, and with the usual rules of matrix multiplication, we'll go through this one quickly. So we'll get A11, B11 plus A12, B21. Then we're going to get A11, B12 plus A12, B22. We'll just try and avoid any mistakes here. Then we get A21, B11 plus A22, B21. That's the thing with these proofs, they can be a little bit fiddly, but they're not like theoretically too complicated. So that's why they're nice exercises to get you used to matrix multiplication, and just get more practice with that, and then understanding what we actually mean by the transpose of a matrix. And then we're going to take the transpose of this, so we're going to get AB transpose, and that just means we swap the rows in the column, so this row here becomes a column. So essentially what we're going to do is just swap over these two elements. Okay, so this is the first column, so it becomes the first row. So now we get A21, B11 plus A22, B21. Down the bottom here, we get A11, B12 plus A12, B22. And in the bottom, the diagonal elements stay the same. Plus A22, B22. And if you look, you can actually see that these two matrices are the same. So we'd want some sort of closing statement, obviously, justify a little bit more than this. It's just when you stop and go to the left hand side, it's easier to see these are equal rather than working. Sorry, not these two equal. This one and this one. It's easier to see it that way, but you could then go back and follow this all the way through and get to here. Oh, well, from here you can go back to there, back to there. Thanks for watching the video. We'll be back with more regular uploads soon. Comment below anything in particular you want to see. Hope you enjoyed the video, and I hope to see you in the next one.